Good morning. News at a glance. Today's main headlines are: Scientists discover CFC is not alone in destroying ozone. There is another culprit. While climate change continues to affect the mainlands, the cold frigid regions of Antarctica and the Arctic are no different to it. While the role of chlorofluorocarbons or CFC has been widely established, an international team of researchers has found a new element that is damaging the ozone over Arctic. The new culprit is iodine. Over 100 researchers from 20 countries, including the Indian Institute of Tropical Meteorological, Pune, in collaboration with Extreme Environments Research Laboratory, Switzerland, the Cyprus Institute, and NOAA Physical Sciences Laboratory, joined hands to analyze the changes in the Arctic. The researchers found that the chemical reactions between iodine and ozone were the second highest contributor to the loss of surface ozone. Their findings have been published in the journal Nature Geosciences after the observations were conducted by the researchers during the ship-based multidisciplinary drifting observatory for the study of Arctic climate expedition. The new findings are set to change the decades-old paradigm on the drivers of Arctic photochemical ozone loss. Now, what is ozone? The ozone layer is found in the troposphere, the lower 10 kilometers of the atmosphere, and in the stratosphere that extends 10 to 50 kilometers above the ground. According to the World Meteorological Department, ozone is a form of oxygen and molecules carrying 3 atoms instead of 2 and acts as a shield protecting us against harmful ultraviolet radiation from the sun. The ozone has been under attack from chlorine, chlorofluorocarbon CFC, and bromine, halon, compounds that were largely being used in refrigerants, pesticides, solvents, and fire extinguishers. This led to the development of a major hole in the ozone layer, which has since then closed. The main driver for this is the anthropogenic emissions of chlorofluorocarbons. However, similar but shorter-lived ozone depletion events are seen close to the surface of the Earth. IITM said in a statement, adding that during this depletion events, ozone concentrations drop to nearly zero. How is iodine damaging ozone? The team of researchers conducted observations from March to October 2020 on a ship in the high Arctic region and found that iodine enhances springtime tropospheric ozone depletion. They developed a chemical model to show that chemical reactions between iodine and ozone are the second highest contributor to the loss of surface ozone. The study further suggests that the atmospheric increase in iodine loading due to enhanced anthropogenic ozone-induced ocean iodine emissions, as well as the thinning and shrinking of Arctic sea ice expected in the near future, while probably lead to increases in iodine emissions. These results indicate that iodine chemistry could play an increasingly important role in the future and must be considered for accurate qualification of the ozone budget in the Arctic, IITM said in a release. That's all for today. Thank you and have a great day.